So we're going to take these one at a time. So bag of words, right? Again, it's one of the simplest methods and earliest. And it's really just an algorithm that counts how many times a word appears in a document. So the word counts allow one to compare documents and gauge their similarities for applications like search and document classification. So in this little table, right, we've got 3 documents, and you would take each word in the document, which would then be a very long vector. This is a short one of four words, and you look at how many times, for example, in the first row, car is represented in document 127, document 24, and document 324, right? So these, documents, at least 1 and 3 are generally about cars and autos, and so basically it's just a counter, it's just a word count algorithm, and they, basically can allow us to compare documents and gauge their similarities. And so again, each of the documents in the bag of words has a vector that contains a vector of the similar length that will contain all the words. And of course, in some documents no words will appear. So for example, in document 1, insurance doesn't appear at all, but it would have that row in its vector. So of course, one of the things about bag of words, right, is that there's no context, okay? And we'll talk about that. And the more complicated the models get, the more they try to build context into the representation. And what else? Yes, and then the probabilities that surpass certain levels will activate nodes in the network and influence the document's classification. So, I mean, the words car, auto, insurance, and best. Well, best might be a positive word, but basically, it's a matter of the words that are associated most with positive sentiment that get the highest classification.